What is the image of a set? To understand it, we start with the two key ingredients. First is the definitional function that we saw previously, and the second ingredient is a subset of the domain of that function. So let's see an example. Let's recall our labeling function, which assigns the elements of the set X, which consists in the set of fruits in your local supermarket, assigns to these elements the set Y of labels. We find here our set of favorite fruits, and since the labeling function maps each one of these elements into these, then we say that the entire set A is mapped into its image set, which we denote by f of A. Mathematically, our set f of A is defined as follows. So f of A is by definition the following set. The set whose elements are the labels y belonging to the codomain, big Y, but we don't want just any label, we want those labels for which exists a fruit in big X which is assigned to that label. Let's look more closely into the element U test for our set, because as it stands is neither true nor false. Once I specify a label y that makes it true, that is a y for which there exists a fruit attached to it, then that label y, well, it's approved, and so it enters in f of a. Now, with this definition in our hands, let's see some examples. The specific function we are going to use is a function s of x, which is by definition just 2 times x. And the set that we are going to consider is a set A, which is just contains 3 elements from -1, 0, and 1. Geometrically, this set essentially is centered at 0, 1 unit to the left, 1 unit to the right. So when I act with this function s, which note is a bijective function, this gives us what? Well, -2, 0, and 2. Now, what is the difference between A and S of A? Well, let's see. This one is centered at 0, so as this. But now the neighbor elements of 0, here is +1 or -1, here is twice of that, is 2 and -2. So essentially, a set centered at 0, +1, -1, now it's twice of that. So the set became into a wider set. Now, let's consider a second function, c of x. And c of x is x divided by 2. If I now act with c on a again, so we get c of a, which is the set, well, it's -1f, 0, and 1f. And so you can see now that previously the set is 0, 1 to the left, 1 to the right, okay? And now it becomes just half of it, okay? So the set was compressed. So you can see that by acting with functions on these sets, you can either stretch a set or contract a set. Notice that the intermediate point, the 0, did not change in this when we apply these functions, okay? But that is because the middle point of A is exactly 0. If it was not 0, for example, if I consider the set A prime, which is equal to 1, 2, and 3, well, if I now act with S, so S of A prime is the set of 2, 4, and what? 6. Let me make a picture just to illustrate the idea. This is the real line, R, so it's the domain of our function S. In this real line, we find the set 1, 2, and 3, okay? And after I act with the function S, I get 2, I get 4, and I get 6, 5, 6 here, okay? So it's like this. So notice what the set did. this is A prime, and in pink you find S of A prime. So not only the set got wider, twice as wide, additionally, the middle point moved from here, which was 2, the 2 here, it was updated to 4. Okay? By acting with C on A prime, then we get C of A prime is, well, it was 1F. The middle point, which is 2, now becomes 1. And finally, 3 becomes 3Fs. A smaller set, and the middle point of that set was shifted. Okay? It was shifted to the left. As our second example, let's consider still the same set A that we find here, -1, 0, and 1. But now let's choose new functions. The new functions are the function L of x, which is by definition x minus 1, and the function R of x, which is equal to x plus 1. You can immediately see that just from the letters R and L, that these two functions have something to do with horizontal shifts or the set on which they act. So we again consider the set A, -1, 0, and 1. So it's centered at 0, but now if I act with L on our set A, notice what happens. You get, well, -1, -1, which is -2, then -1, and then 0. So the entire thing shifted to the left, okay? Analogously, if I act now with R on the set A, what do I get? Well, I just sum to each one of these elements the number 1. And so I get 0, 1, and 2. But note, where is the middle point? The middle point here is 0. Here is -1, so it shifted to the left. Here is +1, so it shifted to the right. But the neighbors of -1 is 0 and -2. Okay? So it is 1 unit apart. So it did not stretch, nor did it compress the thing. L and R make horizontal shifts, but they preserve how wide the sets are. Okay? So let's now move to a more sophisticated example now.